Hello, everyone. Today we're going to look at Lecture 18. Lecture 18 is going to cover the fifth step to the five-step process for hypothesis testing. This is our last real lecture video. I will post some more videos. I will post additional videos to go through a full hypothesis test and maybe some other things, but this is really like the last lecture, full lecture video. So today I'm going to share my screen with you as usual, right? And we'll take a look at the notes and walk through this last step together. So today's last step for this process is the conclusion step. So just like the name, it's the conclusion. We're going to make a conclusion and we are going to make a conclusion statement. This step is actually the only step out of the 5 steps that only has 2 parts instead of 4 parts. So in this conclusion, we're going to compare our p-value, which is our probability, with our alpha, which is our level of significance. So this is where the alpha is coming in. And we're going to determine if our sample can support the new idea, VHA, the alternative view. Okay. So just keep in mind that p-value is the probability, right? That's what we calculated, that area under the curve, either to the right or to the left of our test statistic that we got last time. And we used our calculator for that. Just gonna scroll down here. Okay. So if the p-value is less than or equal to alpha, okay, so if it's further in the tails than alpha, meaning it's smaller than alpha, then it's unlikely that our null hypothesis is true. Meaning it's unlikely that the null hypothesis is the center of the curve, okay? So the idea here is that if the test statistic that we calculated from our sample, if that's really far from the center, then our probability will also be will be small because it's far from the center. Then the idea is that if we have a small probability and it's smaller than our alpha, which our alpha usually is 5%, but it could change depending on the problem, then maybe our center really isn't the center after all, right? Because we're using the center to test or to calculate that test statistic. And maybe if our probability is really small, meaning our test statistic, our sample's really far from the center, then maybe the center in that common view really shouldn't be the common view anymore. The thing is with the conclusion is we're testing our goal, which our goal was in our population step. Our goal always matches our HA. So we're testing for support for that HA. Okay. Our conclusion statement is always about our goal. It's always about our HA. It's never about the null hypothesis. Okay. So when you look at this step and it only has 2 parts, we're going to ask ourselves, is our p-value, our probability, less than our level of significance, or alpha? We have 2 ways of answering this, right? It's either a yes or no. You're always going to ask yourself this same question right here. You are never going to change this inequality. You're always going to say, is the p-value less than alpha? You're never going to flip that inequality around. It's always less than. So is my p-value less than alpha? I can answer yes. If I answer yes, then we can reject our null hypothesis. And our sample does show support for our goal, our new idea. Or if we answer no, that our p-value is not less than our alpha, then we cannot reject our null hypothesis, that common view. And our sample does not show support for our HA, for our goal. So what I want you to notice, and I colored this, so it's all green or all red, that if you answer yes, it's all positives, right? Yes, can, does. Or it's all negatives. No, cannot, does not. And you could always follow this no matter what type of problem we have. If it's numerical or categorical, our conclusion step is going to be the same thing. We're always going to compare the p-value to alpha and wonder if it's smaller than that, right? So when I shade in that tail, if it's less than, my alpha, then I'm going to say yes, can or does, or no, cannot, does not. Okay. So here's my step. Here's the two parts. So I'm going to ask myself that question, okay, and I'm going to make a statement, yes, then I can reject my no, or no, I cannot reject my no. That's all you have to write. You don't even have to write anything different than those. You don't have to put it in context. Then you're going to make a conclusion statement. Now this conclusion statement needs to be in context, and I look for key things in this statement. So I look for my alpha, my level of significance, and you write it as a percentage right here, okay? And then I want you to talk about the sample, if it does or does not support evidence for your goal. So these three things are what I look for, right? And these are the things you're plugging in, and you can use this statement. Oops, I forgot my quotes here. You can use the same statement and just plug your information right into it. That works for me. Whoops, there we go. Okay, so when you're looking at this, it says that I can say my goal. I don't want you to tell me that. I want you to write out the goal that you wrote in your population step. And what's nice is if you took the time to write a nice goal that makes sense in your population step, you can write the same exact goal again here. You don't have to come up with a new idea or a new goal or new wording. If you take the time in population step, then you already have your wording and you can use the same thing again here. It just makes life easier. So remember, the goal matches the HA statement. Okay, that's my population step. It's a really quick, easy step. So let's take a look at the examples. Of course, we're going to continue with example 1 and example 2 from the last couple classes. So example 1, I'll refresh your memory, is the idea that more than 67% of RIT students approve of the university's admin. So here we have the first 4 steps that we just finished, and now we're going to move on to the conclusion step. There's no calculations here, right? We already did everything. We already did all the work. Now it's just trying to see what's going on. So my results, I got a p-value of 0.0229. That's what I'm comparing to alpha. My alpha is 0.05. I don't know if it was stated or if I'm just assuming that, but we stated it in the method step either way. I don't see where it's stated in the original problem, which is okay. A lot of times it's not. A lot of times we just assume it's 5%, unless it's like a medical life or death situation, and we would have stated it right here. So I'm going to compare this 0.0229 to the 0.05, and I always want to know, is my p-value less than alpha? So is 0.0229 less than or equal to 0.05? Yes. We can reject the no. That's exactly what I would want you to write. Now I'm going to say at the 5% level of significance, our sample does show support to say that. Now if you look back up here at the goal, it's like I copied all of this and pasted it right down here. More than 67% of all RIT students approve of the university's administration. My conclusion, again, never says anything about the no. The only place it comes in is right above, that we can reject the no, okay? So if we're rejecting the no, we're just saying, okay, well, maybe that's not the center. I don't know what the center is. I'm not testing for that. I'm just saying, well, maybe that's not the center, and maybe this actually is true because my sample data was so far from the center. That's the idea. All right, let's take a look at example 2. So again, we already have all this information. This is the weight of the apples. So we found here our p-value to be very small, right? It said like 0 on our calculators, but we don't actually say 0. We say very small. A 0 probability is not an option here. So is very small less than 0.05? Yes. If you're saying very small, that means it's smaller than 0.05 because you don't have any numbers there to represent what it actually is, right? So yes, then we can reject the no. At the 5% level of significance, our sample does show support to say that the population mean weight of apples is less than 6 ounces. So when I'm grading something like this with a conclusion step, I'm looking for this first line. I want to know what you're looking at and your answer. Yes, can reject the null. That's what I'm looking for. Again, here I'm looking for the 5% level of significance. So this is telling me, my level of significance is telling me if I can reject that null. So it's telling me if it's significant enough. right? And that's why we lower that down to 1% for medical, life or death, because I don't want to throw out this common view of something that's medical if I'm not really certain that that could be thrown out. Does that make sense? So I don't want to throw out that common view for something medical very easily, right? I want to make sure I have a low level of significance, and that's why we lower it to 1%. But keep in mind that a problem can have anything. You're going to see another problem I'm going to do, and I'm going to tell you it's 10%. It's just what I'm choosing. It's not a guessing game. I will give you the level of significance. If I don't give you a level of significance and you have to determine whatever you tell me your level is up here in the method is what I will grade your work on. So if I give you a medical problem, but you don't know if it's life or death, and you choose 5%, I'm fine. Or if you decide to choose 1%, I'm fine with that as well, and I would grade your work based on those values, just so you know. It's not a guessing game. It's not about that, okay? So when I'm grading this, I'm looking at my 5% level of significance. It's very important to me to know what my level of significance is. And I want to see that you say this, that our sample does, or if it's a no, does not support, and I want the goal. And for the goal, I don't want you just to say goal. I want a full sentence, a full statement about our problem in context. Okay, I'm very particular when I read those. Okay, let's see. We have another example, and I'm actually going to do this example right now on the recording. I figured I would wait and type it all up here. So, well, we're on here together. Okay, so for this example, it says 85% of American adults eat salad at least once a week. A nutritionist suspects that the percentage is higher. A survey of 200 American adults finds that 171 of them do eat salad at least once a week. Using a 0.1, so it's 10% level of significance, show the complete testing process. This is the type of problem you could see on an exam or going forward when you're in Stat 2. So I just give you this information. I expect you to take it from there and go forward. So I'm going to start with my population step. Let's see here. I don't really want my spacing to be that spaced out. So I got to change this real quick before I start typing, because or else I won't have room. Hopefully that fixed it. Okay, so in my population step here, my objects, the first thing I want to define. So my objects, this is who I'm studying. Now remember, it doesn't always have to be people, but in this case it is. So here, this is all American adults. All right. Now the next one is my variable. So this is what's changing from person to person. Now with a categorical variable, which that's what I have here, it's the question that I can just reword here. How do I know this is categorical? Well, first of all, we're talking about do people eat salad or not, and it's a percentage, right? When you're reading the problem, you should know right away if it's categorical or numerical. If it's talking about like the amount of something, like the amount of time, or the amount of salad they ate, or how much someone weighs or something like that, that's numerical, right? So anytime you see like an amount, then you can know that that's numerical. This isn't that. This is, do they eat salad once a week? Yes or no, right? So it's a category someone fits in. So I'm just going to write that. Do they eat salad once a week? And then I always do this. Yes, no. Then I know, oops, then I know that it's just a yes or no question that was asked. Okay? My unknown here. Since we already know the unknown, which is P, right? Because it's proportions. So I'm going to say P is the population proportion. Now I'm going to use the two right above it, the objects and the variable together. Of American adults who eat salad, so it's what I'm interested in, at least once a week. Oops. Okay, so that's P. I'm defining P, so then I can use P going forward, and it's already defined. Now my goal, this is where I want to take a little bit of time and write a nice goal. So I'm going to wait on the goal, and I'm going to go down my method step and write the HA and my null first. You're going to see sometimes I do them side by side to save space. So here's my HA. I'm going to start with my HA. So we know it's proportions, it's P, right? So I want to read the question again to see what she's interested in. A nutritionist suspects that the percentage is higher. So she thinks it's greater than 85%. So I'm going to say P is greater than 0.85. Now I can write my null two different ways. I can write P is less than or equal to 0.85. Whoops. 0.85. Let me backspace this a little bit. Sorry, sometimes it's trickier on my laptop than it is on my desktop. Okay. Or I'm just going to put in parentheses so you know, or you can write it as P is equal to 0.85. So either one. Okay. You can write either way. Doesn't matter to me, means the same thing. Now here under my method step, I want to continue and I want to identify what alpha is. So I'm going to insert a symbol to bring in alpha. I'm going to state alpha is equal to 0.10. And then I want to state what curve I'm on. It's proportion, so I'm on the Z curve here. Okay. Just space this out a little bit better. There. So there's the 4 parts to my method step. That's like one of the quickest steps. So after that, I have my sample step. So this one's pretty quick as well. I'm going to pull all my information out of my sample that I have. So here I could state what N is equal to. It always capitalizes it when I write it first. So N here is 200. And then I'm going to state what X is. And that is 171. And then I'm going to insert an equation because then I have this little accent, possibly. Oh, I don't know if it's going to let me do it. Oh, it's not responding. Terrific. So I had this little accent thing in my equations, and I can find the little one that has just a little hat on it. So I can use P hat. So right here's my accent. Sorry, it's really slow. You can just write P dash hat. That works as well. Now it's kind of too late because I'm already in it. But anyways, we can divide X divided by N there, and we'll get 0.855. So this might be really slow, and I don't know if it's going to let me get out of it without responding. Sorry about that. Let me just give it a second here. I don't really want to get out of this if I don't have to. Oh, I forgot to go back up to my goal, didn't I? After I'm done typing this in, I will go back to my goal. Okay, here it is. So it's the one in the upper right here, has this little hat, and it even says hat. I'm going to click on that, and then I'm just going to click in the box here and put my lowercase p. There it is, my p hat. Now, I'm just going to space it out. Oops, not like that. Arrow over, equals. I'm going to put in a fraction so I can show that it's X divided by N. I'm just going to put 171 divided by 200. I'm just going to arrow over again, equals 0.855. There it is. You don't have to go into that much detail. You could just write P dash hat and calculate it on your calculator and say it's 0.855. That's fine with me. I just like to show it all. Okay, now I need to assume normality in order to trust my results, I want to say. Not to move forward, but we want to say, okay, I don't want to trust my results unless I've met my requirement of normality. So I want to know, is this normal? So in this one, this is where I'm checking N, which is 200, and I'm going to multiply it by the center of my curve. So it's not the 0.855, it's not the p hat, it's the p naught. So it's the 0.85, okay? And times 1 minus 0.855, okay? So I have that there. And that value is, I don't know if I have it here. I could just recalculate it quickly, but I think I have it right here already. Maybe. I do. 25.5. So I want to know, is this greater than or equal to 10? And I'm not even, I keep forgetting to take that off, 10. I'm not even going to say, I'm just going to say yes, normal. You don't need to show me the 25. It's fine. If you tell me the calculation is greater than that, I believe you, but this is what I want to see. I want to see, to make sure you're plugging in 0.85. Sorry, I typed it in here wrong. 0.85 and not 0.855, okay? All right, let's go back up to the goal so we can finish that population step. My goal matches my HA. I'm going to take this HA and I'm going to put it into words. I'm going to say I want to find support, or I want to find sufficient evidence, something like that, or I want to show that, and then you're going to say your HA. So instead of saying HA, you're going to put it into words, which you already have it into words because you have P defined right above. Okay, so I'm going to say to show support, to say that the population proportion, since we're doing this all in Word, we could just copy and paste, of American adults who eat salad at least once a week is greater than 85% or 0.85, either one works, okay? So let me just format this. So that's what your goal would look like, okay? So there it is. All right, so let's move on to our next step. We've got our first 3 steps done. Doesn't take too long. This is the longest one, the results, which we learned last lecture. So the results here, I'm in proportions. I didn't mean to. I hit all sorts of things I don't mean to in my laptop. I want to calculate my z-test statistic. I call this a z-test stat. The reason why it's a statistic is it's based on a sample. That's what a statistic is. So in this value, this is equal to, I'm not going to plug in all of them. I'm hesitant to use my equation because it was kind of giving me trouble before. So my test statistic, it's a fraction, first of all. And it's my p hat, which is 0.855 minus my p naught, 0.85, divided by the standard error. And the standard error is the square root of a fraction. You guys get to see how I use my equation editor here a little bit. I think all the word programs have this, so anyone can use this. Remember, here's my p naught as well. So it's 0.85 times 1 minus 0.85 in the numerator divided by n, which is 200. So here I have equals. I'm just going to show this. And that way, if you guys go back and look at this, you have the values. I don't know if I even have them here. I might have to recalculate. So I have, just going to calculate my denominator here. And get this in here. Okay. So here, my denominator, I'm showing 0.0252488. Okay. Sometimes I leave it really long so I have a more accurate answer because I don't want to have like a mistake. I don't know, like I don't want to cut it off too early, right? I don't want to round too much and then have the answer not be right. So, or as accurate. So here, and then I'm gonna arrow over and equals and divide that by the denominator. And I get 0.198, or you could say 0.20. So I'm just going to put equals 0.20. Could go either way. Okay, probably close enough. All right, so that's my test statistic. I need to interpret this test statistic. So I'm going to say here, my p hat is 0.20 standard errors above because it's positive my center, which is 0.85. So that's, I'm saying, kind of shorten that statement, and that's fine with me. I normally do the abbreviation myself. Now I'm going to calculate my p-value. So my p-value here is equal to the probability that another z-value is greater than or greater than and equal to. You can kind of go either way with it, because it's not like algebra here. My 0.20. So I want to visualize what's going on here. So I have this curve, and my my test statistic is only 0.2, so it's not very far from the center. So when I think about it, I'm not expecting a small probability. I'm expecting a large probability. So it's not very far from the center of the curve. And now I'm going to calculate this. So here, go into my distributions, right? I'm looking at my normal CDF. So for my TI-84 plus, it's the second one. And my lower bound is 0.2. My upper bound is like 10,000 or 10 to the power of 10, 0 and 1 for my center and spread. And I get a probability, exactly what I was thinking, 0.4207 or 42%. I'm going to leave it like that. So I have 42%. That's really big. Okay. So now I want to make a statement about this. So if the center really is the center, so if the population proportion is 0.85, then we get a 0.42 probability. So then there is a 42% chance, or a 0.42 probability of getting, another statistic or another sample proportion at least as extreme as the one we got from our original sample. So you can kind of make it your own. Oops. Okay, kind of make it your own. There we go. Line it up. So there's my interpretations. Now there's my results. That's the longest one. Now we can go into the conclusion. My conclusion step is short. So is 0.42 less than or equal to 0.10? No. We cannot reject the null hypothesis, okay? So now I'm going to go on to my conclusion statement at the 10% level of significance. Our sample data does not, show support to say, and now you could just copy and paste your goal, or you can just retype it, that the population proportion of American adults who eat salad at least once a week is greater than 85%. Okay. There it is. There's our statement, and it has everything we're looking for. My level of significance. If my sample does support it or does not support it, remember it matches this, all negatives, no, cannot, does not, and then support my goal, right? My HA. So that's my conclusion. So maybe the center is at 0.85. Maybe it is 85%. Maybe I shouldn't be throwing that out. Okay. So that's what we're looking at with that example. I hope that helped, having me go through a full example for you guys. I know that's sometimes a little long. I know these take you guys a long time. So when I assign Any of the team assignments, I want you to know that I don't expect you to spend more than 3 hours on our class. So if you're spending an hour on each lecture, just looking at the notes and watching the videos, I don't expect you to fully complete a team assignment if it's going to take you 2 hours, right? Our class is a 3-hour-a-week meeting time, and that's exactly what I expect you to do. So if you're only spending maybe an hour on the lecture notes in the week, then maybe spend a little extra time on the team assignment. So just talk over with your teammates, see where you're at. It's if you don't complete something, I don't take points off for that, right? So I just want you to understand that. I don't want you to think that you have to spend like 8 hours a week on our class, right? So our in-class time should be the same as it was before, and then plus your homework assignments, okay? And you know, if you spend any extra time studying. So I will be available Monday, Wednesday at 12:30 and Friday at 12 for any questions you guys may have. I just hang out in the chat for anything, so you can come in and ask me if you have any questions, or if you just want to chat, you want to have someone to talk to. I'm probably not your favorite person to talk to, but I'll be there. All right. Okay, have a great day, and I will see you soon.